So today we're going to look at what's really at the core of all the kinds of mathematical work that we can do in chemistry that relates the amount of one thing to the amount of something else. So if we're running chemical reactions, we would like to be able to say, well, if I start with this much reactant, how much product can I make? Or if I know I want to make this much product, how much reactant will I need? And we really want to be able to relate the different amounts of stuff that participate in a chemical reaction. And the only way to do that is to use moles. So we will eventually tie this into grams, but not today. Today we're going to look at the relationships between the moles of the different reactants and the moles of products and how those relate to each other. And you have to start with moles, and no matter what kind of problem you end up doing, this conversion of moles of one thing to moles of something else will be right in the middle of that. Now, for the first day of that, we're going to use what's called the BCA method. And BCA stands for before, that's the B, change, that's the C, and after, that's the A, so BCA. And it involves setting up a grid like I have on the board here. So let's start with this chemical reaction. We've got potassium and chlorine reacting together to make potassium chloride. Now, if you actually saw this going on in a container, it would be quite exciting because it would be lots of flame and light and all kinds of stuff going on because this is a very exothermic reaction. It releases a lot of heat. But on the board, it doesn't look nearly that exciting. But this would look like a chunk of metal. This is a yellow gas, and if you put them together and get them going, it's going to make this white crystalline solid, potassium chloride, which is not exciting at all. And people use this as a salt substitute on their food if they can't have salt. All right, so anyway, before, here's what we're going to be given in the problem. We're going to be told that we're starting with 10 moles of potassium. And our questions will be, how many moles of chlorine will I need to make sure I have enough to react all the potassium? And when I get all done, how much of this will I make? So we can do that even if we only know that because we have a balanced chemical equation and we can see the relationships of the moles of one thing and the moles of something else because that comes from these numbers. So every time 2 moles of potassium reacts, it requires 1 mole of chlorine for that reaction, and it will produce 2 moles of KCl. So if we know we're starting with 10 moles of this, and we know that we're going to use it all up, then we say that the change is a negative 10 moles. Okay, so this right here, this row going across is really kind of what we need to focus on for these kinds of problems. So let's look, we're going to use up 10 moles of this, and we've got a 2-to-1 ratio. So every time 2 of these reacts, 1 of these needs to react. So can you kind of see where we're going here? We need to have half as many moles of this as of this. So I'm going to say half times 10 moles. Now, I know you can do that in your head, but it's okay. I'm going to write it out this way so that later on, if you're looking back at this in your notes or something, you would remember where did the number 5 come from. All right, and then we'll move on and say, let's see, 2 and 2. All right, so that's the same. That's a 2-to-2 ratio. In other words, 1-to-1, but we usually leave it 2-to-2. And say that if I use 2 moles of this, I'll make 2 moles of that. Okay, so that's actually my mole ratio, and I'm going to multiply that times the 10 moles. In other words, because this number and this number is the same, however many moles of this I use, that's the number of moles of this I will produce. So I want to make sure that in terms of the change, I'm using 10 moles of this, I'm producing 10 moles of that. And you can see that multiplying it by 2 over 2 is not going to change it. And by the way, that should be a plus sign because we're making this, and this should be a minus sign because we're using that up. All right, so when this is all done, then we are using up all of this, and that will be 0. We're also using up all of this, so this will be 0, which leads me to believe that at the beginning I must have started with 5 moles. Okay, what happens over here? This is a product. We always start with zero product. And then if we're adding this much, that means that I end up with 10 moles when I'm all done. So here we have everything we might want to know. How much do we start with of everything? How much do we finish with of everything? What was the change that went on? So no matter what the problem asks me, I can answer those questions with that. All right, let's try another one. Let's see. We have 2 LBr3. So we got aluminum bromide and chlorine gas again, that yellow poisonous gas. So we're going to change this up just a little bit because I kind of like to have you see the different kinds of problems that you might be given. And in this one, we're going to be told, we're making the math easy here, by the way. We're going to be told that you're starting with 0.2 moles of aluminum bromide, and you're told that you're starting with excess chlorine. So what does that mean? That means that when the reaction finishes, we're going to have chlorine left over. It means that this will be used up and that won't be, and we don't need to know how much of that we start with because this extra. All right, also starting with no products. So we look again, we're going to do our math with this row going across. So if we look at that, we can see that every time I use 2 of these, I have to use 3 of these. So chlorine will always be 3/2 as much as aluminum bromide. So if I think about the change, well, maybe we better put what aluminum bromide is first. All right, this, because we're told that this is the limiting reactant, this is the one that will be completely used up, then we're going to put that in as being completely used up. Okay, now we can go to that step that I was just going to go to. So chlorine is always 3/2 as much as aluminum bromide. In other words, we always use more chlorine than we use of that. And so, do the math, we'll do it that way. Like that. Okay, now how about this? That's a 2 and that's a 2, meaning that we always have the same amount of those two in terms of what goes on in the chemical reaction. So again, we'll stick with this change row. 2/2 is my mole ratio, and we'll multiply that again times the number I actually have. So we want to make sure that whatever we're using up here is the same as what we're producing here. So 2/2 does that. I know you could reduce that to 2/1, but if I'm looking at your work and I want to know where did your numbers come from, if you start reducing your mole ratios, then I'm not going to be sure where your numbers came from. So even if it's 5/5 or 10/10 or whatever it is, just leave those numbers there and don't reduce them. Okay, now what's happening over here? So we're going to make 3 of these for every 2 of these. And I keep going back here because that was my given number. So for bromine, we're producing 3/2 times the amount that was used up over here. So 0.2 is used up over here. 3/2 times 0.2 over to be produced over here. So this number is going to be bigger than that number, and that makes sense because this number is bigger than this number. So we're always using those coefficients as mole ratios. All right, so what do we end up with? Let's see. If we divide that by 2, we get 0.1, so 0.30, 0.20, and 0.30 moles in every case. So even if we are only given one quantity, we can go from there and find out all the quantities of what happened in the chemical reaction as long as we have a balanced chemical reaction to start with.